Algebra. It's a beautiful day here at Squaw Valley. Today, we're going to learn all about the slope of a line. To be ready for this program, you'll need a paper and pencil. If you have it, graph paper would be really helpful. Let's go.
There's a special American message coming in. It's a mathematical adventure about to begin. You can see what this crazy world is all about. If you find a solution before time runs out, you're gonna find the answer. It's operation algebra. Time is not for action, so investigate. There's a world of equations and negotiations. No hesitation, it's operation algebra.
The slope of a line. As we go along, take notes and try the practice problems yourself. By the end of this program, you'll know what is meant by the slope of a line. And you'll be able to find the slope of a line in many different situations. For example, you'll be able to look at the graph of a line and use a tool called a slope triangle to find the slope of that line. You'll also learn how to determine the slope of a line without using a graph. This can be done if you know the coordinates of 2 points on the line and the formula for slope. You'll also learn to identify slopes of lines as positive, negative, 0, or undefined. And you'll learn how the value for the slope of a line can tell you something about the steepness of a line and the direction it goes. Finally, you'll learn to draw a line through a given point with a given slope. Understanding the concept of slope and how the slope determines the steepness of a line is a key concept in linear algebra. When put together, these ideas about slope should help you make sense of why the lines look the way they do, and how the patterns in numbers and tables and equations relate to pictures on a graph. These skills are also useful in real-life situations where you're dealing with problems in construction or architecture, or when you're interested in rates of change. We have 3 main objectives for today. They are: 1, to learn to find the slope of a line through 2 given points. 2, to identify how the slope of a line relates to its direction and steepness. And 3, to learn to draw a line through a point with a given slope. Are you ready to learn more? Let's go to the math lab. What do you think of when you hear the word slope? You might think of how something slants, either uphill or downhill. Do you want to know what I think of when I hear the word slope? When I think of the word slope, I think of ski slopes and the beautiful mountains in the California Sierras. While this may not seem like a good place to talk about math, it's actually an incredible location. We're here to talk about mathematical slope, or the steepness of a line. And what better place to talk about steepness than here in the mountains? Come on, I'll show you. Many of the roads in the Sierras are cut right out of the mountain. Some are so steep that they can be dangerous for truck drivers who carry heavy loads or who have trouble with their brakes, especially when the roads are icy. For safety purposes, signs are posted on the roads to inform drivers when there's a steep hill ahead. A sign like this one tells drivers exactly how steep the road is so they can proceed safely. But what does this sign really mean? What's a 5% grade anyway? If a hill has a grade of 5%, it means that for every 100 feet you travel horizontally, you gain or lose 5 feet vertically, depending on which way you're driving. So, driving down this hill, for every 100 feet of horizontal change, there's a vertical change of 5 feet. This pattern repeats itself as long as the road maintains the same grade. Sometimes the vertical change is referred to as the rise, and the horizontal change is referred to as the run. The ratio of rise to run is called slope. The slope of a line describes its steepness or rate of change. Let's take a closer look at rise and run. One way to find the slope of a line is to use the rise and run to make a slope triangle. To do this, there are a few things you need to know about measuring the rise and run. When you move to the right in the positive direction on a graph, your horizontal change, or run, is positive. And when you move to the left in the negative direction on a graph, your horizontal change, or run, is negative. Likewise, when you move up in the positive direction on a graph, your vertical change, or rise, is positive. And when you move down in the negative direction on a graph, your vertical change, or rise, is negative. Let me show you how this works. Say you want to measure the slope of this line. First, pick 2 points on the line where you can clearly read the coordinates from the graph. These should be places where your line intersects the corners of the squares on the graph paper. Next, using the graph paper lines as a guide, draw a right triangle, marking your path from one point to the other. It doesn't matter which point you start with and which point you end with. For example, I can start at this point and rise 2 spaces up in the positive direction, and then run 3 spaces over in the positive direction to reach the other point. Or I can start at this point and rise 2 spaces down in the negative direction, and then run 3 spaces over in the negative direction to reach the other point. The triangles that are formed by marking the rise and run from one point to the next are called slope triangles because they help you find the slope of the line. As we've seen, slope is equal to rise over run. To find the slope of this line, then, we just put the rise and run into the formula and solve for the slope. We can use the information from any triangle along the line, so long as the rise and run come from the same triangle. So, using this triangle, where the rise is -2 and the run is -3, the rise over run is -2 over -3, which is just 2/3. This tells us that this line has a slope of 2/3. If we use the other triangle, where the rise is 2 and the run is 3, the ratio of rise to run remains 2/3, again showing us that this line has a slope of 2/3. Therefore, the slope, 2/3, describes the steepness of this line. It means that if we start at any point on the line and rise up 2 units and run over 3 units, we'll end up at another point on the same line. We can keep doing this over and over. The slope is constant along the entire line. Therefore, no matter what 2 points you choose to draw your triangle, you will find the same value for the slope. For example, what if we pick these 2 points to make our slope triangle? This point and this point. To go directly from one point to another, we can rise up 6 units and run over 9 units. Using these values to compute the slope, the rise over run is 6 over 9, which reduces to 2/3. So you see, regardless of which 2 points you choose to make your triangle and which direction you choose to draw your triangle, there's only one value possible for the slope of a particular line. And drawing a slope triangle to help find the ratio of rise to run is one way to determine that value. This sign is a perfect example of a slope triangle. The rise is 5 and the run is 100. Slope is equal to rise over run. So the slope of a road with a 5% grade is equal to 5 over 100, which reduces to 1 over 20. Therefore, though it's not drawn to scale, the slope of the line representing this road is equal to 1 over 20. But you don't always need to use a slope triangle and find the ratio of rise to run to find the slope. Come on, let's hit the ski slopes and I'll show you another way to find the slope of a line. What's the slope of this line? We've already seen how to find the slope of a line using a slope triangle. We pick 2 points on the line, draw in a slope triangle, find the rise and the run, and compute the ratio of rise to run to find the slope. But we can look at this whole process in a different way. If you know the coordinates of 2 points on the line, you can find the rise, the vertical change, and the run, the horizontal change, without counting squares. For example, to find the vertical change or rise between the 2 points, you can find the difference between their y coordinates. Let me show you. We've got the coordinates of 2 points on the line. The y-coordinate of this point is 3, and the y-coordinate of the other point is 4. Subtracting the y-coordinates will give us the vertical change from one point to the other. 3 minus 4 is -1. So -1 is the vertical change, or the rise between the 2 points. Likewise, to find the horizontal change, or run, between the 2 points, we just find the difference between their x-coordinates. So let's look back to the points. The x-coordinate of this point is 5, and the x-coordinate of the other point is 2. Subtracting the x-coordinates will give us the horizontal change from one point to the other. 5 minus 2 is 3. So 3 is the horizontal change, or run, between the 2 points. Since rise over run is the slope of the line, this method also tells us that the slope of this line is -1 over 3, or -1/3. Subtracting coordinates provides us with another way to find the slope of a line. To use this method, all you need to determine the slope of a non-vertical line is the coordinates of 2 points on that line. These coordinates are used in a formula to find the slope. Now, before I show you the formula for the slope of a line, I want to explain a few pieces of algebraic notation that are commonly used in finding the slope. In algebra, to represent the coordinates of 2 different points, we use this notation. The sunken numbers following the x's and y's are called subscripts, and the notation is read x sub 1, comma y sub 1, and x sub 2, comma y sub 2. The subscripts are used to help distinguish between different pairs of coordinates. Since we need to deal with several points at once, it's important to know which point you are talking about. Typically, the first point is called x sub 1, comma y sub 1, and the second point is called x sub 2, comma y sub 2. Take a look at how this notation is used in the formula for slope. The formula for slope says that if you're given the coordinates of 2 points on a line, x sub 1, comma y sub 1, and x sub 2, comma y sub 2, the slope is equal to the difference in the y-coordinates, y sub 2 minus y sub 1, over the difference in the x-coordinates, x sub 2 minus x sub 1, so long as x sub 2 does not equal x sub 1. As we've seen, this formula makes sense. Subtracting the y-coordinates gives us the vertical change, or the rise, and subtracting the x-coordinates gives us the horizontal change, or the run. Subtracting the coordinates gives us another way to find the rise and run from one point to another. Before we move on, let's take a closer look at this formula. Notice that in both the numerator and the denominator of the formula, the coordinates from point 1 are subtracted from the coordinates from point 2. This is the trick to using the formula for slope. You must be very careful to use both coordinates from one of the points as the first number in the subtraction problem, both in the numerator and in the denominator. Likewise, you must use both coordinates from the other point as the number that's subtracted in both the numerator and the denominator. To keep things straight, it's often useful to call one of your points point 1 and the other point point 2. It doesn't matter which is which, so long as you can keep them straight. So let's do the same problem one more time, but this time pay close attention to the order that things are subtracted. Again, here's the line. On this line, we found the points 2, 4, and 5, 3. If we call this point 1 and this point 2, we call the coordinates of point 1 x sub 1, y sub 1, and the coordinates of point 2 x sub 2, y sub 2. The formula tells us that slope is equal to the change in y sub 2 minus y sub 1, over the change in x sub 2 minus x sub 1. Y sub 2 minus y sub 1 is 3 minus 4, and x sub 2 minus x sub 1 is 5 minus 2. Notice how the coordinates from point 2 appear first, and the coordinates from point 1 appear second in both subtraction problems, the one in the numerator and the one in the denominator. Keeping this straight is the key to the slope formula. Once the problem is set up, the rest is simple. All you have to do is subtract to find the slope. In the numerator, 3 minus 4 is negative 1. And in the denominator, 5 minus 2 is 3. That makes the slope equal to negative 1 over 3, or negative 1/3. That means if you start at any point on the line and make a vertical change of negative 1, followed by a horizontal change of 3, you'll end up at another point on the line. Since all parts of the line have the same slope, the slope, negative 1/3, describes the steepness of the line.
I'm definitely enjoying the slope out here. Let me go up and ski another line, and we'll use the formula to find the slope. I'll see you at the top.
So, what's the slope of this line? This time, since we have no grid lines that we can use to count the rise and the run, we'll have to use the formula for slope. To use the formula, we'll have to pick one of the points as point 1 and the other as point 2. If we call this point point 1 and this point point 2, y sub 2 minus y sub 1 will equal 1 minus 2. And x sub 2 minus x sub 1 will equal 4 minus 2. Simplifying in the numerator, 1 minus 2 is negative 1. And in the denominator, 4 minus 2 is 2. That makes the slope equal to negative 1 over 2, or negative 1/2. So, if you start at any point on the line and make a vertical change of negative 1, followed by a horizontal change of 2, you'll end up at another point on the line. Since all parts of the line have the same slope, the slope, negative 1/2, describes the steepness of the line.
Yeah!
At this point, you may be wondering, what if I picked the points in a different order? What if I made 2, 2, point 1, and 4, 1, point 2? I told you that it doesn't matter which point you make point 1 and which point you make point 2, as long as you keep things straight in the formula. But so you can be sure, let's switch things around and find the slope again. So, let's make this point point 1 and this point point 2. How will you use the information in the formula for slope? The formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If 4, 1 is point 1 and 2, 2 is point 2, y sub 2 minus y sub 1 will equal 2 minus 1. And x sub 2 minus x sub 1 will equal 2 minus 4. Then, simplifying the numerator, we have 2 minus 1, or 1. And in the denominator, 2 minus 4 is negative 2. That makes the slope equal to 1 over negative 2, which is the same as negative 1/2. It does not matter which ordered pair you choose as point 1 and which ordered pair you choose as point 2. What does matter, though, is that you stay consistent. So once you pick a point as point 2, The coordinates of that point must appear first in the numerator and the denominator. If you keep your work neat and clearly label your points, you should do fine.
Now that we found the slopes of a few lines together, see if you can do one on your own. Try this.
So what's the slope of this line? Okay, how'd you do? Remember, the formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you called 1, 2, point 1, and 2, 1, point 2, you would find y sub 2 minus y sub 1 equal to 1 minus 2, and x sub 2 minus x sub 1 equal to 2 minus 1. Simplifying, you would find 1 minus 2, or negative 1, in the numerator, and 2 minus 1, or 1, in the denominator. That makes the slope equal to negative 1 over 1, which can also be written as just negative 1. If, however, you called 2, 1, point 1 and 1, 2, point 2, after doing the calculations, you would find the slope equal to 1 over negative 1, which, as we just saw, is the same as negative 1. This answer, slope equals negative 1, brings up another interesting point. That is, that while we think of slope as the ratio of rise to run, in some cases the slope can be written as a whole number. In these cases, just think of the whole number as a fraction, written as the number over 1. For example, just as the number negative 1 can be written as the fraction negative 1 over 1, a whole number slope like negative 1 can be written as a fractional slope, negative 1 over 1. So a line with slope negative 1 is the same as a line with slope negative 1 over 1. A slope of negative 1 means that if you start at any point on the line and make a vertical change of negative 1, followed by a horizontal change of 1, you'll end up at another point on the line. Since all parts of the line have the same slope, the slope, negative 1, describes the steepness of the line.
You may have noticed that the lines I skied all had negative slopes. While this may seem like a coincidence, it actually makes perfect mathematical sense. All lines with negative slopes share an important characteristic. That is, they all slant downhill as you read them from left to right. You see, the slope of the line is not just a random number. The slope of the line is a specific number that tells you something about the direction of a line and how steep the line will be. My friend Randy is an excellent skier, and I've asked him to join us today to help me show you all the different ways that a line can look, and to help me explain how the value for the slope of a line can tell you a lot about how a line will look on a graph.
Lines can be classified in 4 ways. As you read from left to right, they can go downhill, or reading from left to right, they can go uphill. Lines can also be horizontal, and lines can be vertical. And the value for the slope of a line can be negative, positive, 0, or undefined. The direction of the line and the value for the slope of that line are related. If you know the value of the slope of a line, you'll know what direction the line goes. And if you know the direction that a line goes, you'll know something about the value of its slope. For example, lines that go downhill always have negative slopes. This is because on a downhill line, if you draw a slope triangle from one point to another, your rise will always be negative, and your run will always be positive. Therefore, the slope, or ratio of rise to run, will always be negative, since a negative number divided by a positive number is always negative. Lines that go uphill always have positive slopes. This is because on an uphill line, If you draw a slope triangle from one point to another, your rise will always be positive, and your run will always be positive. Therefore, the slope, or ratio of rise to run, will always be positive, since a positive number divided by a positive number is always positive. The slope of a horizontal line is 0. This is because on a horizontal line, you cannot draw a slope triangle. To get from one point to the other, you do not rise at all, so your rise will be 0. And since you can move horizontally in either direction to get from one point to another, your run can be either a positive or a negative number. So the slope will always be 0, since 0 divided by any non-zero number, positive or negative, is always 0. The slope of a vertical line is undefined. This is because on a vertical line, it's impossible to draw a slope triangle. Vertically, to get from one point to another, you can move either up or down. So your rise can be either a positive or a negative number. But since the points are right on top of each other, you can't move horizontally in either direction. So your run must be 0. The slope, or ratio of rise to run, will be undefined, since any number divided by 0 is undefined. You can't have 0 in the denominator. Because the slope of a vertical line is undefined, we often say that it has no slope. Here are a few tricks to help you remember which is which. Think of a skier skiing on a graph. A skier on a line that slopes down from left to right skis downhill. If you think of down as negative, you can remember that lines that go downhill have negative slopes. A skier on a line that slopes upward from left to right goes uphill. If you think of up as positive, you can remember that lines that go uphill have positive slopes. If a skier is on a horizontal line, he can't go up or down. A skier on a flat surface like this would have 0 problem. Think of this to remember that the slope of a horizontal line is 0. It's impossible for a skier to ski on a vertical line. It's so steep that we say it has no slope. This image might help you remember that the slope of a vertical line is undefined. Think you've got it down? There are lines all over the place. Check out these lines on the Bay Bridge. As you see each one, try to classify its slope as positive, negative, 0, or undefined. So, the slope can tell you something about the direction of a line.
Slope can also tell you how steep a line actually is.
A horizontal line has a slope of 0. Lines that have slopes that are close to 0 end up looking almost horizontal on a graph.
Lines with slopes that are farther away from 0 will graph as much steeper lines.
Take a look at this. Here is a graph with a horizontal line. Its slope is 0. If we draw in more lines with different slopes, you'll see that the lines with more gradual slopes, those that are closer to horizontal, have slope values that are closer to 0. Likewise, the steeper lines have slopes that are farther away from 0.
The same is true of lines with negative slopes. The lines with gradual slopes, the ones that are closer to horizontal, have slope values that are closer to 0, and the steeper the lines get, the farther away from 0 their slopes are.
To sum it up, the value for the slope of a line can tell you how steep it is.
The farther away from 0, the steeper the slope.
Another way of saying that is, the higher the absolute value of the slope, the steeper the line will be.
So what does all of this have to do with skiing?
Well, there's many different routes that you can take down any one ski run.
Advanced skiers who often like speed and a challenge will sometimes pick a line that has a much steeper slope.
And less advanced skiers who like to play it safe often look for a way down the hill with a more gradual slope. When we're done, we'll do the math and find the slopes of both lines to see if you were right. Ready?
Who will ski the line with the steeper slope? skied the line with the steeper slope? Was it Pam or was it Randy?
It looks like I skied the line with the steeper slope. But let's check the math out, just to be sure. Remember, the line whose slope has the greatest absolute value is the steeper line. Placing a grid over the lines, we can find the slopes. We'll mark 2 points on each line. Now, we'll draw slope triangles and compute the change in y and the change in x to find the slope. First, let's take a look at my line. My line goes down 1 space for a rise of -1, and over 1 space for a run of 1. That gives my line an overall slope of -1 over 1, which is just -1. Now let's look at Randy's line. Randy's line goes down 1 space for a rise of -1 and over 2 spaces for a run of 2. That gives his line an overall slope of -1 over 2, or -1/2. So how can we use these numbers to prove whose line is steeper? Remember, the greater the absolute value the slope of the line is, the steeper the line will be. My line has a slope of -1. The absolute value of -1 is 1. Randy's line has a slope of -1/2. The absolute value of -1/2 is 1/2. Since 1 is greater than 1/2, and steeper lines have slopes with greater absolute values, we've mathematically shown that I ski the line with the steeper slope. Okay, enough celebrating. Before we finish up today, I want to discuss a typical problem involving slope. That is, how to draw a line with a given slope through a given point. If you're given a point on a graph, there are many different lines that you can draw through that point, and all of those lines have different slopes. But if you want to draw a line through a given point with a particular slope, then there's only one line you can draw that fits the bill. How do you draw a line through a particular point with a particular slope? Let me show you. Let's say you're asked to do the following. Draw a line through point -3, 3 with a slope of -2. Start by plotting the given point, -3, 3, on a graph. From here, you have to draw a line, but you want to be sure to draw the one line through this point that has a slope of -2. Since the slope of -2 can also be written as -2 over 1, you know that your change in y, or rise, is -2, and that the change in x, or run, is 1. Using this information, you can find another point on the line. So, starting from the point -3, 3, we'll rise down 2 and over 1 to find a second point on the line. Then, to finish up, we just draw a line through both points. So, to draw a line through a given point with a given slope, first, plot the point. Then, use the slope to plot another point. Finally, connect the 2 points to draw the line. That will give you the one line of all the lines that can be drawn through the point that has the slope you want. Here, try one on your own. Draw a line through the point 1, -3 with a slope of 2/3. All right, let's see how you did. To draw a line with a given slope through a given point, the first thing you need to do is to plot the point. So, plot 1, -3 on your graph. Next, you use the slope to find another point on the line. The given slope is 2/3, which means that the rise is 2 and the run is 3. So starting at the given point, we rise up 2 and over 3 to arrive at the next point on the line. Once we have 2 points, we can just connect the points to make a line. So this is the line that goes through the point 1, -3 with a slope of 2/3. Not bad for a day's work. Now that we're done talking about mathematical slope, let's hit those ski slopes for one last run. Today, we've gone up and down, learning all about the slope of a line. Hopefully, you'll feel that we've met today's objectives. Again, those were 1. To learn to find the slope of a line through 2 given points. 2. To identify how the slope of a line relates to its direction and steepness. And 3. To learn to draw a line through a given point with a given slope. Take some time to practice finding the slope of a line and using the other skills involving slope on your own. Undoubtedly, wherever you are, you will encounter real-life examples of slope. Whether you're looking at the pitch of a roof, the grade of a highway, or you're analyzing constant rates of change in areas like economics, physics, or statistics, the concepts of slope are at work. The more deeply you understand slope, the more you'll understand about the nature of these everyday examples, and the more connections you'll be able to see between the symbols of algebra, like numbers and equations, and other algebraic representations, like graphs or tables. Seeing these connections will make math make more sense, and will help you to use the idea of slope to understand other phenomena. Algebra is power. See you next time. Okay. Hi. 5, 3.
See what this crazy world is all about. If you find a solution before time runs out, we're gonna find the answer. It's observation algebra.
There. Oops, too far. Stop.
There's a world of equations to negotiate, so no hesitation.